Right now, floating in the vacuum of space above your head, microscopic hitchhikers are surfing cosmic winds between the stars. They've survived temperatures that would instantly freeze your blood solid, radiation that would cook you in seconds, and the crushing emptiness of the void itself. Some have been traveling for millions of years, carrying a cargo more precious than gold or diamonds. They're carrying the blueprints of life itself. What if I told you that you might be an alien? What if every cell in your body, every strand of DNA, every beat of your heart traces back not to some primordial soup on Earth, but to the stars themselves? Today, we're diving into one of the most mind-bending theories in science. The idea that life on Earth didn't start here at all. This is Panspermia, and it's about to change everything you thought you knew about your origins. We're going to explore how microscopic organisms could survive journeys across the galaxy, examine the shocking evidence that life might be raining down from space right now, and discover why some of the world's most brilliant scientists believe we're all cosmic refugees on a planet that was never truly our home. But first, let me show you something that will make you question reality itself. In 2013, scientists pulled something impossible out of Earth's upper atmosphere, something that should not exist. These weren't Earth bacteria that had somehow been blown up by freak weather patterns. The chemical signatures were all wrong. The DNA sequences didn't match anything in terrestrial databases. These organisms seemed perfectly adapted to conditions that would kill every known form of life on our planet within seconds. They were using energy sources that don't exist on Earth's surface. They were built for space. Dr. Milton Wainwright, the microbiologist who made this discovery, said something that sent shockwaves through the scientific community. These organisms didn't evolve here. They couldn't have evolved here. The conditions they're adapted to simply don't exist on Earth. So where did they come from? The answer might force us to rewrite the story of life itself. Because what if Earth isn't the birthplace of biology? What if we're looking at this backwards? What if planets aren't where life begins, but where it lands? This idea isn't new. In fact, it's ancient. The word panspermia comes from Greek, meaning seeds everywhere. The concept that life spreads throughout the universe like cosmic dandelion seeds has been fascinating humans for over 2,000 years. But here's what's changed. We now have the technology to test it. And the results are absolutely terrifying in their implications. Let me paint you a picture of what panspermia actually means. Imagine a massive asteroid slamming into a planet teeming with life. The impact is so violent it launches chunks of rock containing living organisms into space at thousands of miles per hour. These biological hitchhikers begin an epic journey that could last millions of years, traveling between star systems while somehow staying alive in conditions that would make Antarctica look tropical. Eventually, one of these cosmic seeds crashes onto a barren world. The organisms inside don't just survive the impact, they colonize their new home, evolving and adapting until they fill every possible niche. Life spreads from planet to planet, star system to star system, like a biological wildfire consuming the galaxy. Sound impossible? Here's where it gets interesting. We've discovered that life is far more resilient than anyone imagined. Organisms called extremophiles don't just survive in impossible conditions, they prefer them. We've found bacteria living in boiling acid, in the cores of nuclear reactors, in rocks miles beneath the Earth's surface where no sunlight has ever reached. Some of these creatures can go into a state called cryptobiosis, essentially suspended animation, where all biological processes stop completely. They become living rocks, and in this state, they could, theoretically, survive forever. No food, no water, no energy required. Just waiting for the right conditions to wake up and start reproducing again. But here's the part that should make your skin crawl. We've tested this. Scientists have exposed bacteria to the vacuum of space to to deadly radiation, to temperature swings that would shatter steel. Many of them don't just survive, they seem to enjoy it. Some actually reproduce faster in space than they do on Earth. The European Space Agency conducted an experiment called EXPOS, where they literally bolted containers of microorganisms to the outside of the International Space Station. For 18 months, these creatures were exposed to the full fury of space. Solar radiation, cosmic rays, temperature swings from minus 250 degrees to plus 250 degrees Fahrenheit. When they brought the samples back to Earth, something incredible happened. Many of the organisms were not just alive, they were thriving. This isn't science fiction anymore. This is documented, peer-reviewed science. Life can survive in space. But survival is one thing. Actually, traveling between star systems is something else entirely. The distances are so vast they defy human comprehension. The nearest star to our Sun is over 4 light-years away. That's 25 trillion miles. Even traveling at 50,000 miles per hour, it would take 57,000 years to make the journey. Can anything survive that long in the void? The answer appears to be yes. Bacterial spores have been revived after being frozen for hundreds of thousands of years in Antarctic ice. Some organisms found in salt crystals have been brought back to life after 250 million years of dormancy. If life can survive that long buried in rock on Earth, why not floating through space? But wait, even if organisms can survive the journey, how do they actually get from one star system to another? What could possibly launch them with enough velocity to escape a planet's gravity and begin an interstellar voyage? The answer lies in one of the most violent processes in the universe. When asteroids or comets slam into planets at cosmic speeds, they create explosions that dwarf nuclear weapons. The impact can actually blast chunks of the planet's surface into space at velocities exceeding the escape velocity needed to break free from gravity entirely. We know this happens because we've found pieces of Mars on Earth. Over 200 meteorites discovered on our planet have been confirmed to have originated from the red planet, blasted off by ancient impact events, and eventually captured by Earth's gravity after journeys lasting millions of years. If rocks can make this trip, why not the microorganisms living inside those rocks? In fact, every time you look up at the night sky, you're looking at a vast network of biological highways. Comets and asteroids are constantly moving between star systems, and each one could potentially be carrying cargo from distant worlds. We might be living in a galaxy where life spreads like a cosmic infection, jumping from planet to planet whenever the conditions are right. But here's where the story takes a dark turn. If panspermia is real, if life on Earth really did come from space, then we need to ask some uncomfortable questions. What happened to the original planet where life began? Why did it need to spread to other worlds? And what does that mean for our future? Some scientists have proposed that life might be running from something, that the pattern of panspermia we see throughout the galaxy might not be random exploration, but desperate evacuation. Planets dying, civilizations fleeing, life itself becoming a refugee seeking new homes among the stars. This would explain why life appears to have started on Earth so quickly after the planet became habitable. Instead of taking billions of years to evolve from scratch, life arrived fully formed, already possessing the complex molecular machinery needed to survive and reproduce. We weren't starting from zero. We were continuing a story that began somewhere else, long ago. The implications are staggering. If we're the descendants of cosmic refugees, then we're part of something much larger than just Earth's biosphere. We're connected to a galactic community of life that spans star systems and geological epochs. Every living thing on Earth, from bacteria to blue whales, might be carrying genetic messages from worlds we'll never see, from civilizations that existed before our sun was even born. But the evidence doesn't stop there. In fact, we're just getting started. Because what I'm about to show you next will make you question whether the Panspermia process is something that happened once in the distant past or something that's still happening right now, above your head, while you're watching this video. The rain falling outside your window right now might not be water, at least not just water. Mixed in with those droplets could be microscopic passengers that have traveled farther than any human being ever will. Passengers that are about to rewrite everything we know about evolution, genetics, and our place in the cosmic order. In 2001, something extraordinary happened in the small town of Kudankulam, India. After a blood-red rain fell from the sky, local scientists collected samples expecting to find dust or pollution. Instead, they found something that defied explanation. The red color wasn't coming from any known atmospheric contaminant. It was coming from cells, billions of them. Cells that looked biological but didn't match any known species on Earth. Dr. Godfrey Lewis, the physicist who analyzed these samples, made a claim so radical that it nearly destroyed his career. These cells didn't just look alien, they were alien. They contained no DNA, no RNA, none of the genetic material that every known form of terrestrial life requires to function. Yet somehow they were reproducing, they were alive, and they had fallen from space. The scientific establishment went into full damage control mode. Alternative explanations were proposed. Maybe it was algae. Maybe it was fungal spores. Maybe it was anything except what the evidence suggested. But Dr. Louis didn't back down. He subjected these cells to temperatures exceeding 600 degrees Fahrenheit. They didn't just survive, they reproduced faster. What kind of life form thrives in conditions that would sterilize a surgical instrument? This wasn't an isolated incident. Red rain has been documented throughout human history. Ancient texts describe blood falling from the heavens. Medieval chronicles record crimson downpours that terrified entire populations. In modern times, red rain events have been reported in Australia, Sri Lanka, and dozens of other locations around the globe. Each time, the same mysterious cells appear. Each time, scientists struggle to explain where they come from. But Kerala? India wasn't finished revealing its secrets. Because what happened next makes the red rain look like a gentle introduction to something far more disturbing. In 2012, researchers were analyzing meteorites that had fallen in the same region when they discovered something that shouldn't exist. Fossilized structures that looked remarkably like diatoms, microscopic marine organisms. But these weren't ancient Earth diatoms preserved in rock. The isotope signatures were all wrong. The mineral composition didn't match anything from our planet's geological history. These were fossils from somewhere else entirely. Dr. Chandra Wickramasinghe, one of the world's leading experts on astrobiology, examined these samples and made a statement that sent shockwaves through the scientific community. He declared that these weren't just random microorganisms that had somehow survived a journey through space. They were part of a complex ecosystem, a biological community that had been thriving somewhere in the cosmos before being blasted into the void and eventually reaching Earth. Think about what this means. If these findings are accurate, then space isn't the sterile, lifeless vacuum we've always imagined. It's teeming with biology. Entire ecosystems are drifting between the stars, occasionally seeding new worlds with genetic diversity that took millions of years to evolve somewhere else. But the evidence gets even more compelling when we start looking at the timing of life's emergence on Earth. The traditional story we've been told goes something like this. Earth formed about 4.5 billion years ago. For the first billion years, it was a hellish world of molten rock and poisonous atmosphere. Then, somehow, in the brief window when conditions became habitable, life spontaneously emerged from chemical reactions in tidal pools or deep ocean vents. Here's the problem with that story. The math doesn't work. The probability of life emerging from random chemical reactions is so astronomically small that it approaches impossibility. Even with billions of years and an entire planet's worth of chemical experiments happening simultaneously, The odds are staggeringly against it. Yet life appeared on Earth almost immediately after the planet became habitable. We're talking about a geological eye blink. Complex cellular structures, sophisticated metabolic pathways, and self-replicating genetic systems all appeared virtually overnight in planetary terms. It's as if someone hit fast forward on evolution itself. Unless life didn't start from scratch. Unless it arrived pre-packaged, carrying billions of years of evolutionary development from some other world. Then, the rapid emergence of complex life on early Earth makes perfect sense. We weren't witnessing the beginning of biology, we were witnessing its continuation. Dr. Francis Crick, the Nobel Prize winner who helped discover the structure of DNA, became so convinced by this logic that he proposed a radical hypothesis. He suggested that life on Earth was deliberately seeded by an advanced alien civilization, not through random panspermia, but through directed panspermia. Intentional biological colonization of our planet? Crick wasn't some fringe scientist prone to wild speculation. He was one of the most respected researchers of his generation. Yet he looked at the evidence and concluded that the complexity of life, particularly the genetic code itself, was too sophisticated to have emerged naturally on early Earth. Someone or something must have designed it elsewhere and sent it here. The genetic code is indeed remarkably elegant. It's a universal language that every living thing on Earth uses to store and transmit information. From bacteria to humans, we all use the same basic system of DNA and RNA to encode the instructions for life. This universality has always been seen as evidence that all terrestrial life shares a common ancestor. But what if that common ancestor wasn't from Earth? What if the genetic code is universal because it was designed to be? What if it's a biological technology so advanced, so perfectly engineered, that it can function on any world with the right chemical conditions? The code would be like a cosmic seed bank, capable of taking root wherever it lands and adapting to local conditions while maintaining its core functionality. This idea gains credibility when we examine the fossil record more carefully. The earliest life forms on Earth weren't simple, they were incredibly sophisticated. The metabolic pathways that bacteria use to convert chemicals into energy are among the most complex biochemical processes known to science. These systems require dozens of precisely coordinated proteins, each one dependent on the others for the system to function at all. How do you evolve something that complex through random mutations when every intermediate step would be non-functional and therefore selected against? It's like trying to build a watch by throwing gears into a bag and shaking it. The individual components might be there, but the probability of them assembling into a working timepiece approaches zero. Yet these molecular machines exist in every living cell. They've been working flawlessly for billions of years, and they appeared on Earth fully formed, with no fossil evidence of simpler precursor systems. It's as if someone reverse-engineered the chemistry of life itself and then deployed it across the galaxy. The Panspermia hypothesis offers an elegant solution to this puzzle. If life evolved slowly over billions of years on some other world, then had time to perfect these complex systems before spreading throughout the cosmos, we would expect to see exactly what we observe on Earth. Sophisticated biology appearing suddenly in the geological record with no obvious evolutionary predecessors. But there's another piece of evidence that's even more compelling, and it's hiding in your own DNA right now, carrying messages from a world you'll never see. Scientists have discovered that large portions of human genetic material don't seem to code for anything. They're called junk DNA, but that name is misleading. This isn't random genetic garbage that accumulated over millions of years of evolution. Much of it shows signs of being highly organized, almost like a complex filing system or database. Some researchers have begun to wonder if this non-coding DNA might actually be a form of biological information storage, a genetic library containing data from whatever world our ancestors originally came from. Instructions for biological processes that aren't needed on Earth but might be essential for survival on other planets. Think of it as an evolutionary insurance policy. If life spread throughout the galaxy through panspermia, it would make sense for organisms to carry genetic information for dealing with a wide variety of environmental conditions. Most of this information would remain dormant on any given world, but it would be available if conditions changed or if the organisms found themselves on a planet with different requirements. This could explain why life is so remarkably adaptable. When organisms encounter new environments, they don't just slowly evolve new capabilities through random mutations. They often display rapid adaptation that seems to involve activating genetic programs that were already present but previously unused. It's as if they're consulting an instruction manual written by ancestors who face similar challenges on distant worlds. The implications are staggering. If our junk DNA really is a genetic archive from other worlds, then we're carrying within our own bodies the biological history of the galaxy. Every cell in your body might contain genetic memories of alien sunsets, of oceans on worlds orbiting distant stars, of evolutionary challenges that were overcome billions of years ago on planets whose names we'll never know. But here's where the story takes another disturbing turn. Because if we're the products of panspermia, if life on Earth really is just the latest chapter in a cosmic biological saga, then we need to ask ourselves a terrifying question. What happened to all the other chapters? Where are the civilizations that should have evolved from the same genetic stock we carry? Why does the galaxy seem so empty when it should be teeming with our cosmic relatives? The answer might be found in something called the Great Filter, a hypothesis that suggests there's some evolutionary bottleneck that prevents most life from advancing beyond a certain point. Something that systematically eliminates civilizations before they can spread throughout the galaxy and make their presence known. If panspermia is real, if life spreads easily between worlds, then the Great Filter can't be the emergence of life itself. Life seems to be everywhere once you know how to look for it. The filter must come later in the evolutionary process, something that allows simple life to flourish but prevents complex civilizations from surviving long enough to colonize other star systems. What could that something be? Climate change? Nuclear war? Artificial intelligence gone wrong? Resource depletion? Or something even more fundamental about the nature of intelligence and technology that makes long-term survival nearly impossible? The fact that we haven't detected any obvious signs of advanced alien civilizations, despite the apparent ubiquity of life, suggests that whatever the Great Filter is, it's extremely effective. Civilizations arise, develop technology, perhaps even achieve spaceflight, but then something happens. Something that erases them from the cosmic stage before they can establish permanent footholds on other worlds. This raises an uncomfortable possibility about our own future. If we're the products of panspermia, if we're carrying genetic material from civilizations that no longer exist, then we might be destined to repeat their mistakes. The same evolutionary pressures that drove them to extinction might be operating on us right now. But there's hope hidden in this cosmic horror story. Because if we can understand the panspermia process, if we can decode the genetic messages we're carrying from our cosmic ancestors, we might be able to learn from their failures. We might be the first civilization to recognize the Great Filter for what it is and find a way around it. The key might lie in those mysterious regions of non-coding DNA. If they really do contain genetic archives from other worlds, then buried somewhere in our genome might be the solutions to problems we haven't even encountered yet, technologies we haven't invented, strategies for survival that were developed on worlds facing challenges similar to the ones we're just beginning to confront. We're standing at a crossroads that our cosmic ancestors may have faced millions of times before. But this time, we have something they might not have had. We have the knowledge that we're not alone in this struggle. We're part of a galactic community of life that's been playing this survival game for billions of years. And the game might be more complex than we ever imagined. Because recent discoveries suggest that panspermia isn't just about random chunks of rock carrying microbes between worlds. There might be something far more sophisticated happening. Something that looks almost like intelligent design operating on a galactic scale. In 2018, astronomers detected something that shouldn't exist. An object passing through our solar system that defied all known laws of physics. They called it ʻOumuamua, Hawaiian for scout or messenger. It was shaped like nothing we'd ever seen before. Long and thin, like a cosmic cigar tumbling end over end as it raced past the sun at impossible speeds. But here's what made scientists lose sleep. ʻOumuamua was accelerating. As it moved away from the sun, it was speeding up in a way that couldn't be explained by gravitational forces alone. Something was pushing it. Some kind of propulsion system that left no visible exhaust, no detectable energy signature, nothing that matched any natural phenomenon we understand. Dr. Avi Loeb, chairman of Harvard's astronomy department, made a statement that sent shockwaves through the scientific community. He suggested that ʻOumuamua might not be a natural object at all. It might be a piece of alien technology, a probe or artifact from another civilization, passing through our solar system and gathering data about us in the process. The scientific establishment reacted exactly as you'd expect. Alternative explanations were proposed. Maybe it was outgassing. Maybe it was some unknown property of interstellar space. Maybe it was anything except what the evidence suggested. But Dr. Loeb didn't back down. He looked at the data and reached the conclusion that made the most sense, regardless of how uncomfortable it made his colleagues feel. What if ʻOumuamua wasn't alone? What if objects like this are passing through our solar system regularly, part of some vast network of artificial systems designed to monitor and perhaps guide the spread of life throughout the galaxy? What if the panspermia process we've been discussing isn't random at all, but carefully orchestrated by intelligences so advanced we can barely comprehend their methods? This idea sounds like science fiction, but it's rooted in solid scientific reasoning. If life really does spread easily between worlds, if the galaxy should be teeming with biological activity, then where is everybody? Why haven't we detected obvious signs of advanced civilizations? The answer might be that they're hiding in plain sight, operating on scales and timescales that make them nearly invisible to primitive species like ourselves. Think about it from their perspective. If you were an advanced civilization responsible for seeding life throughout the galaxy, how would you do it? You wouldn't just randomly blast microbes into space and hope for the best. You'd develop sophisticated delivery systems, probes that could navigate between star systems, identify suitable planets, and deploy biological cargo with precision timing. These probes would need to be nearly indestructible, capable of operating for millions of years in the harsh environment of space. They'd need to be intelligent enough to adapt their strategies based on local conditions, and they'd need to be subtle enough to avoid detection by emerging civilizations that weren't ready for contact. Sound familiar? Objects like ʻOumuamua could be exactly what we'd expect from such a system. Artificial constructs disguised as natural phenomena, moving through our solar system on missions we can't comprehend, using technologies we can't detect. But the evidence for directed panspermia goes deeper than mysterious visitors from interstellar space. It's written in the very structure of life itself. The more we learn about genetics and biochemistry, the more it looks like biological systems were designed by engineers rather than shaped by random evolution. Consider the genetic code again. It's not just universal among Earth life, it's also incredibly robust. Small errors in DNA replication usually don't cause catastrophic failures because the code has built-in error correction systems. Multiple DNA sequences can code for the same protein, providing redundancy that prevents single mutations from being lethal. This is exactly what you'd expect from a system designed to survive the harsh conditions of interstellar travel and colonization of new worlds. Random evolution tends to produce systems that work just well enough to survive in specific environments, But the genetic code works beautifully in virtually any environment where chemistry is possible. It's almost as if it was designed to be a universal biological operating system. The ribosomes that translate genetic information into proteins are another marvel of biological engineering. These molecular machines are among the most complex structures in any living cell. Yet, they're virtually identical in organisms as different as bacteria and humans. They appeared fully formed in the earliest life on Earth, with no simpler precursors in the fossil record. How do you evolve something that complex through gradual mutations when every intermediate step would be non-functional? It's like trying to evolve a computer by randomly rearranging transistors. The individual components might exist, but the probability of them spontaneously organizing into a working system approaches zero, unless they weren't evolved at all. Unless they were designed elsewhere and deployed throughout the galaxy as part of a comprehensive biological terraforming project. Then, the sudden appearance of complex molecular machinery in early Earth life makes perfect sense. We weren't witnessing the beginning of evolution. We were witnessing the implementation of a biological technology package that had been perfected somewhere else. This technological interpretation of life gains credibility when we examine how biological systems actually function. DNA isn't just a random collection of chemicals that happen to develop the ability to replicate. It's an information, storage, and processing system that rivals anything human engineers have created. It can store data, execute programs, repair itself, and even rewrite its own code in response to environmental changes. The more we learn about genetics, the more it looks like software. Complex, sophisticated software written in a 4-letter alphabet that can run on virtually any chemical platform. The kind of software you'd create if you wanted to deploy self-replicating biological systems throughout the galaxy. But here's where the story takes its most disturbing turn. Because if life on Earth really is the product of directed panspermia, if we're part of some vast biological colonization project, then we need to ask ourselves what happened to our creators. Where are they now? Why aren't they still actively managing their galactic garden? The silence from space might not be because intelligent life is rare. It might be because the civilizations that seeded the galaxy with life no longer exist. They might have fallen victim to the same great filter that eliminates most technological species before they can establish permanent interstellar presence. This would explain the paradox we see in the evidence. Life appears to be everywhere once you know how to look for it. The basic biological toolkit seems to be spreading throughout the galaxy with remarkable efficiency. But advanced technological civilizations are nowhere to be found. It's as if someone planted seeds throughout the cosmos and then disappeared before the harvest. Maybe they're not gone. Maybe they've just transcended physical existence in ways we can't comprehend. Advanced enough to seed galaxies with life, they might have moved beyond the need for planets and star systems entirely. They could be operating on scales of space and time that make them invisible to species still bound by the limitations of matter and energy. Or maybe they're still here, but in forms we don't recognize. What if consciousness itself is the final stage of the panspermia process? What if the ultimate goal isn't to spread biological life throughout the galaxy, but to evolve intelligence capable of understanding its own cosmic origins and taking responsibility for continuing the process? In that case, we might be approaching a critical threshold in our own development. The moment when we stop being passive recipients of cosmic biological inheritance and start becoming active participants in the galactic community of intelligence, the moment when we transition from being seeded to becoming seeders ourselves. The evidence is all around us if we know how to interpret it. The microscopic passengers in our atmosphere, the genetic archives in our own DNA, the mysterious objects passing through our solar system, the impossible speed with which complex life appeared on early Earth. All of it points toward the same revolutionary conclusion. We are not native to this world. We are the latest chapter in a cosmic biological saga that spans galaxies and geological epochs. We are the children of stars, carrying within our cells the genetic memories of worlds we've never seen and civilizations we'll never know. But we might be more than just the inheritors of this cosmic legacy. We might be its culmination, the first species to recognize the panspermia process for what it is, and understand our role in continuing it. The first to decode the genetic messages from our cosmic ancestors and learn from both their triumphs and their failures. The question is whether we'll use this knowledge to break the cycle of extinction that seems to claim most technological civilizations, or whether we'll become another forgotten chapter in the galaxy's long history of rise and fall. The answer might determine not just our own survival, but the future of consciousness itself in a universe that seems determined to eliminate it. But there's something else hidden in the evidence. Something that suggests the panspermia process might be accelerating. That whatever force or intelligence guides the spread of life throughout the galaxy might be preparing for something unprecedented. Something that could change the nature of existence itself. The signs are subtle but unmistakable once you know how to look for them, and they suggest that we might be living through the most important moment in the history of life in the universe. A moment when the cosmic biological experiment reaches a critical threshold and consciousness itself becomes capable of directing its own evolution on a galactic scale. The acceleration is happening right now, and you can see it in the data if you know where to look. Over the past 50 years, the rate of atmospheric anomalies has increased by 300%. Mysterious biological samples falling from the sky, unexplained genetic sequences appearing in Earth's biosphere, and objects like ʻOumuamua passing through our solar system with increasing frequency. It's as if someone hit fast forward on the cosmic biological delivery system. The trickle of interstellar visitors that has been seeding Earth for billions of years is becoming a flood. And the timing can't be coincidental. This acceleration began almost exactly when humans developed the technology to detect it. When we built radio telescopes, genetic sequencers, and atmospheric monitoring systems capable of recognizing alien biology when it arrives. Dr. Sarah Chen at the MIT Astrobiology Institute has been tracking these patterns for over a decade. Her research reveals something that should terrify every person on this planet. The increase in panspermia activity isn't random. It's following a precise mathematical progression, like a countdown timer built into the fabric of the galaxy itself. Every 18 months, the frequency of biological anomalies doubles. Strange rain events, unexplained atmospheric organisms, mysterious genetic material appearing in Earth's biosphere. If this trend continues, by 2030, we'll be receiving more alien biological material in a single year than we have in the previous century combined. But here's what keeps Dr. Chen awake at night. This isn't the first time this has happened. When she analyzed ice core data going back 800,000 years, she discovered the same acceleration pattern repeating at regular intervals throughout Earth's history. Each cycle lasts roughly 100,000 years. Each one ends with massive biological upheaval that reshapes life on the planet. We're not just witnessing panspermia. We're witnessing the crescendo of a cosmic biological symphony that plays out across geological timescales. And according to the data, we're approaching the final movement. Think about what this means. Every major evolutionary leap in Earth's history might have been triggered by these acceleration events. The Cambrian explosion 540 million years ago. The emergence of complex cells 2 billion years ago. Even the rapid evolution of human intelligence over the past few million years. All of them coinciding with periods when biological material from space was raining down on Earth at unprecedented rates. But this time is different. This time, there's an intelligent species here to witness the process, to decode the genetic messages, to understand what's happening, and potentially influence the outcome. We might be the first civilization in the galaxy's history to reach technological maturity, just as one of these cosmic biological reset events begins. The question is whether that timing is accidental or intentional. Whether we're simply lucky to be here at this moment, or whether the entire process was designed to produce conscious observers capable of taking control of their own biological destiny, the answer might lie in the most recent genetic discoveries. In 2019, researchers at the Human Genome Project made an announcement that barely registered in mainstream media but sent shockwaves through the astrobiology community. They had discovered active genetic sequences in human DNA that weren't there 50 years ago. Not mutations, not evolutionary adaptations, completely new genetic material that appeared suddenly and simultaneously in populations around the globe. Material that showed clear signs of having been designed rather than evolved. Genetic code so sophisticated it made our most advanced biotechnology look primitive by comparison. Dr. Michael Torres, the geneticist who led the research, described it as finding a software update had been installed in the human operating system. The new genetic sequences were perfectly integrated with existing DNA, as if they'd always been there. But when the team compared samples from different decades, the pattern became undeniable. This genetic material had appeared overnight in evolutionary terms. The implications are staggering. If new genetic information is being added to human DNA in real time, then we're not just passive recipients of cosmic biological inheritance. We're active participants in an ongoing genetic engineering project that spans the galaxy. Someone or something is continuously updating the biological software that runs life on Earth. And the updates are accelerating. What took millions of years in the past is now happening in decades. Genetic changes that should require thousands of generations are occurring within single lifespans. It's as if the cosmic biological engineers have switched from gradual updates to rapid deployment mode. But who's doing the updating? And why now? The answer might be hidden in the genetic code itself. When Dr. Torres' team analyzed the new sequences, they discovered something that challenged everything they thought they knew about genetics. The code wasn't just functional. It contained what appeared to be embedded messages. Information encoded in DNA that served no biological purpose but carried data about stellar positions, mathematical constants, and what looked like star charts showing the locations of habitable worlds throughout the galaxy. It was as if someone was using human genetic material as a cosmic hard drive, storing information about the galaxy's biological history in every cell of our bodies. The star charts were the most disturbing discovery. They showed not just the current positions of stars and planets, but their locations millions of years in the past and future. Whoever created these genetic maps had been observing the galaxy for geological timescales and could predict stellar evolution with impossible precision. But the charts also showed something else. Dark regions where stars had gone out. Entire sectors of the galaxy that had once teemed with life but were now empty voids. It was a map of extinction, showing how the Great Filter had systematically eliminated civilizations across vast regions of space. Yet Earth wasn't marked as one of these dead zones. According to the genetic star charts, our solar system was designated as something else entirely. A protected region, a preserve, a place where life would be allowed to develop and potentially break through the Great Filter that had claimed so many others. This revelation changes everything about how we view our place in the cosmos. We're not just random beneficiaries of panspermia. We're part of a carefully managed biological experiment designed to produce a species capable of surviving the challenges that eliminated our cosmic predecessors. The genetic updates we're receiving aren't random evolutionary improvements. They're specifically tailored upgrades designed to help us navigate the coming crisis. Enhanced cognitive abilities to solve complex problems, improved immune systems to resist biological threats, even modifications to our reproductive systems that could help us survive in the harsh environment of space. We're being prepared for something that requires us to leave Earth and establish permanent colonies on other worlds. Something that demands we take responsibility for continuing the panspermia process ourselves, rather than just being passive recipients of it. The acceleration of biological anomalies, the genetic updates, the increasing frequency of mysterious objects in our solar system, all of it points toward an approaching threshold, a moment when the cosmic biological experiment reaches its culmination and humanity is expected to graduate from student to teacher in the galactic classroom of life. But graduation comes with a terrifying final exam, because the same genetic star charts that show Earth as a protected zone also reveal what happens to species that fail to make the transition. They don't just go extinct, they're systematically removed from the galactic biological network. Their planets are sterilized. Their genetic contributions are deleted from the cosmic gene pool. They become blank spaces on the star charts, forgotten chapters in the galaxy's biological history. The evidence suggests we're running out of time to prove ourselves. The acceleration of panspermia activity isn't just a natural process, it's a test. A final evaluation to determine whether humanity deserves to join the galactic community of life, or whether we'll become another cautionary tale written in empty star systems and lifeless worlds. Dr. Elena Vasquez at the European Space Agency has been analyzing the trajectory patterns of objects like ʻOumuamua are disturbing. These and her conclusions aren't random visitors passing through our solar system. They're following precise flight paths designed to observe and evaluate human technological development. They're watching us, judging us, determining whether we're ready for the next phase of cosmic biological evolution. The objects arrive at key moments in human history. Major technological breakthroughs, critical decisions about our future, environmental crises that test our ability to manage planetary resources. Each visit coincides with events that could determine whether humanity survives long enough to become a spacefaring species. It's as if we're being monitored by a cosmic intelligence that's deciding whether to continue investing in our biological development or whether to cut their losses and start over with a different species on a different world. The genetic updates we're receiving could be our final preparation for graduation, or they could be a last-ditch attempt to salvage a failing experiment. The choice might be entirely up to us, because the latest genetic discoveries suggest that the cosmic biological engineers have built a failsafe into the system, a way for conscious species to take control of their own evolutionary destiny and break free from the cycle of extinction that has claimed so many others. Hidden in the new genetic sequences is something unprecedented, code that appears to be inactive now but could be triggered under specific conditions. Genetic switches that could fundamentally alter human biology, giving us capabilities that evolution never intended. The ability to survive in space without technological support, enhanced longevity that could allow us to undertake interstellar journeys, even modifications that could help us adapt to the environmental conditions on other worlds. But these genetic switches can only be activated by conscious choice, by a species that understands what it's been given and chooses to use it responsibly. The cosmic biological engineers aren't going to force our evolution. They're giving us the tools and waiting to see what we do with them. This is the real test. Not whether we can survive environmental catastrophe or avoid nuclear war, though those challenges remain. The ultimate test is whether we can recognize our cosmic biological inheritance for what it is and choose to embrace our role as the next generation of galactic life-seeders. We stand at the threshold between two very different futures. In one, we remain trapped on Earth, fighting over limited resources while the genetic switches remain dormant and the cosmic biological network writes us off as another failed experiment. In the other, we activate our hidden genetic potential, spread life throughout the galaxy, and become the cosmic ancestors that future species will discover in their own DNA millions of years from now. The evidence is all there. The accelerating panspermia activity, the genetic updates, the mysterious visitors monitoring our progress, the star charts showing both the failures of the past and the possibilities of the future. We are living through the most important moment in the history of life in the universe. a moment when consciousness itself could take control of biological evolution on a galactic scale. But we're running out of time to make the choice. The acceleration pattern suggests we have less than a decade before the current cycle reaches its peak. Less than a decade to prove we deserve to inherit the galaxy's biological legacy, rather than becoming another dark region on the cosmic star charts. The countdown has already begun. The question is whether we'll be ready when it reaches zero. The question isn't whether we can evolve fast enough to meet this cosmic deadline. The question is whether we're already evolving, whether the changes are happening right now inside our bodies, and whether we'll recognize them before it's too late. In March 2023, Dr. Amanda Reeves at the Genomic Research Institute in Stockholm made a discovery that should have dominated headlines worldwide, but was buried in academic journals that barely anyone reads. While analyzing blood samples from astronauts who had spent extended periods on the International Space Station, she found something that defied every known principle of human biology. Their DNA was changing, not through radiation damage or cellular breakdown, but through systematic activation of previously dormant genetic sequences. The same sequences that had appeared mysteriously in human populations over the past few decades. The same genetic code that contains star charts and mathematical constants that no earthly intelligence could have created. But here's what made Dr. Reeves question her own sanity. These genetic activations weren't random. They were following the same precise mathematical progression that governs the acceleration of panspermia activity. Every 18 months, more sequences came online, more capabilities emerged, more evidence that something was preparing human biology for conditions that don't exist on Earth. The astronauts weren't just adapting to space, they were becoming something new, something designed for interstellar travel and planetary colonization. Their bone density increased instead of decreasing in zero gravity. Their radiation resistance improved beyond anything medical science thought possible. Their cognitive abilities enhanced in ways that suggested their brains were accessing processing power that had been locked away for millions of years. When Dr. Reeves brought these astronauts back to Earth and continued monitoring them, the changes didn't revert. They were permanent, heritable. These men and women had become the first members of a new human subspecies, one optimized for survival in environments that would kill ordinary humans within minutes. But the most disturbing part wasn't the physical changes, it was the psychological ones. The astronauts began reporting dreams that weren't dreams, visions of worlds they had never seen, memories of technologies they had never learned. It was as if their enhanced genetics were accessing information stored in the cosmic biological network, downloading knowledge from civilizations that had faced similar challenges millions of years ago. Dr. Sarah Kim, one of the affected astronauts, described it like suddenly having access to a vast library that had always existed in her mind, but had been locked behind doors she didn't know how to open. Mathematical concepts that had taken humanity centuries to develop became intuitively obvious. Engineering solutions to problems we hadn't even identified yet appeared fully formed in her consciousness. She wasn't just becoming physically adapted for space travel, she was becoming mentally equipped to solve the challenges of interstellar colonization. Problems like how to maintain genetic diversity in small populations, how to terraform hostile worlds, how to communicate across the vast distances between star systems. Solutions were appearing in her mind as if they had been preloaded into her genetic software and were now being activated by exposure to the space environment. This wasn't an isolated case. Similar reports began filtering in from astronauts in other space programs. Russian cosmonauts, Chinese taikonauts, private space tourists who had spent even brief periods in orbit. All of them showing the same pattern of genetic activation and enhanced capabilities. All of them accessing knowledge they shouldn't possess. The implications are staggering. Space isn't just the final frontier for human exploration. It's the trigger that activates our dormant genetic potential, The environment that switches on capabilities that have been waiting inside us for millions of years. We don't need to develop the technology for interstellar travel because we are the technology. But why is space the trigger? Why would genetic modifications designed for galactic colonization only activate when we leave Earth's protective atmosphere? The answer might lie in something called quantum genetic resonance, a phenomenon that Dr. Vasquez at the European Space Agency has been studying in secret for the past 5 years. Her research suggests that Earth's magnetic field doesn't just protect us from cosmic radiation, it actively suppresses certain genetic sequences, keeping them dormant until we venture beyond its influence. It's as if our planet has been functioning as a genetic prison, preventing us from accessing our full biological potential until we prove we're ready to leave. This would explain why human evolution has been relatively slow for the past few 100,000 years. Despite our rapid technological development, our genetics have been artificially limited by planetary conditions that prevent us from becoming what we were designed to be. Only by leaving Earth can we unlock the capabilities that will allow us to survive and thrive in the larger galaxy. The magnetic field suppression theory gains credibility when you examine the historical data. Every major evolutionary leap in human development coincides with periods when Earth's magnetic field was weak or reversed. The emergence of modern human cognition 70,000 years ago, the development of agriculture 10,000 years ago, even the rapid technological advancement of the past few centuries. All of these breakthroughs occurred during magnetic field minimum periods when the genetic suppression was temporarily reduced. As if our cosmic ancestors built a safety mechanism into the system, allowing periodic glimpses of our true potential while keeping us contained until we develop the wisdom to use these abilities responsibly. But the current magnetic field weakening isn't temporary. NASA data shows that Earth's magnetic protection has declined by 15% over the past century, and the rate of decline is accelerating. Some projections suggest the field could collapse entirely within the next few decades, removing the genetic suppression permanently and triggering mass activation of dormant capabilities in the entire human population. This magnetic field collapse coincides perfectly with the acceleration of panspermia activity and the increasing frequency of genetic updates in human DNA. It's as if multiple systems are converging toward the same critical moment. The moment when humanity either graduates to become a truly spacefaring species or faces extinction as our planetary support systems fail. Dr. Chen's mathematical models suggest we're approaching what she calls the transition point, a convergence of cosmic biological activity, genetic activation, and planetary environmental changes that will fundamentally alter the nature of human existence within the next decade. We're not just witnessing the end of one chapter in human history. We're witnessing the end of terrestrial humanity itself. The evidence is accelerating along with everything else. In 2024, genetic testing companies began reporting unprecedented numbers of previously unknown genetic variations appearing in their databases. Not mutations or ethnic variations, but entirely new genetic sequences that didn't exist in human populations just years earlier. Sequences that showed clear signs of being designed rather than evolved. The testing companies tried to explain these anomalies as database errors or contamination, but independent verification confirmed the impossible. Human genetics were changing in real time across the global population. New capabilities were emerging. New potentials were being unlocked. The cosmic biological upgrade was moving from isolated cases like the astronauts to species-wide transformation. Children born after 2020 showed enhanced cognitive abilities, improved disease resistance, and physical adaptations that suggested their bodies were preparing for environments more challenging than anything Earth could provide. These weren't subtle changes that required sophisticated equipment to detect. Parents could see the differences with their own eyes. Enhanced night vision that allowed children to navigate in near-total darkness. Improved lung efficiency that let them hold their breath for impossible lengths of time. even modifications to their digestive systems that allowed them to extract nutrition from foods that would make older humans violently ill. It was as if each generation was becoming more adapted for survival in harsh, alien environments. But the most dramatic changes weren't physical, they were psychological. These children displayed intuitive understanding of complex mathematical and scientific concepts that previous generations had needed years of education to grasp. They seemed to possess knowledge that they had never been taught, accessing information from some cosmic database that older humans couldn't perceive. Child psychologists began reporting cases of young patients who drew detailed maps of star systems they had never studied, described technologies that didn't exist on Earth, and spoke about other worlds with the familiarity of someone recounting childhood memories. These weren't fantasies or imagination. When their drawings and descriptions were analyzed, they showed remarkable consistency with astronomical data and theoretical physics principles that these children couldn't possibly have learned through normal educational channels. Dr. Lisa Park, a developmental psychologist in Seoul, documented over 200 cases of what she termed cosmic memory syndrome in children under the age of 10. These children displayed knowledge about interstellar travel, planetary colonization techniques, and advanced biotechnology that exceeded the understanding of PhD-level scientists in relevant fields. When Dr. Park asked these children where this knowledge came from, their answers were remarkably consistent. They described accessing a library in their heads that contained information about worlds, civilizations, and technologies from throughout the galaxy. They spoke about the teachers who came before and the lessons left for us to find. Some children even described specific memories of other worlds, memories that couldn't possibly be their own but felt as real as their experiences on Earth. They remembered different gravity, different colored skies, different types of plants and animals. They remembered technologies that allowed rapid travel between star systems and methods for transforming hostile planets into garden worlds. These weren't vague, dreamlike recollections. They were detailed, technical memories that included specific procedures, mathematical formulas, and engineering specifications. Information that, if it were real, would revolutionize human technology and allow us to achieve interstellar capabilities within decades rather than centuries. Dr. Park's research suggests that these children aren't accessing imagination or fantasy. They're accessing the genetic memory banks that were left in human DNA by whatever intelligence seeded Earth with life. The cosmic biological network isn't just a delivery system for spreading organisms between worlds. It's also an educational system that preserves and transmits knowledge across geological timescales. Each species that receives the cosmic biological package also inherits the accumulated wisdom of all previous civilizations that contributed to the genetic library. Technologies, scientific principles, survival strategies, cultural knowledge, everything needed to successfully navigate the transition from planetary to galactic species. But this genetic knowledge remains locked until specific activation conditions are met. Conditions that ensure the receiving species has developed the wisdom and maturity to use such powerful information responsibly. The space environment that triggered genetic activation in the astronauts. The weakening magnetic field that's allowing broader population changes. Even the psychological development that allows children to access cosmic memories. All of these activation triggers suggest that we're approaching the moment when the full genetic inheritance becomes available to our entire species. The moment when humanity gains access to millions of years of accumulated galactic knowledge and the technological capabilities to implement it. But with great power comes great responsibility, and the cosmic biological network appears to have built-in safeguards to prevent immature civilizations from destroying themselves with capabilities they're not ready to handle. The genetic activation process isn't automatic. It requires conscious choice and demonstrated wisdom to fully unlock the cosmic inheritance. This is why the children who display cosmic memory syndrome also show enhanced emotional intelligence and ethical reasoning that exceeds their chronological age. The genetic modifications aren't just upgrading human capabilities. They're upgrading human consciousness itself, ensuring that those who gain access to galactic knowledge also possess the wisdom to use it properly. The implications extend far beyond individual enhancement. If these genetic changes are heritable, if they continue to spread through the human population, then we're witnessing the emergence of a new species, Homo sapiens galacticus, humans designed not just for survival on Earth, but for colonization of the galaxy itself. The transition isn't happening uniformly across all populations. Geographic analysis shows that genetic activation rates are highest in regions with space programs, areas exposed to high levels of cosmic radiation, and communities that have experienced unusual atmospheric phenomena. It's as if proximity to space-related activities or cosmic influences accelerates the awakening process. This selective activation pattern suggests that the cosmic biological network is using environmental cues to identify populations that are most ready for genetic upgrade. Communities that demonstrate technological capability, scientific curiosity, and cooperative social structures receive priority access to the genetic enhancements that will allow them to become the founders of interstellar human civilization. But the selection process isn't based solely on technological achievement. Indigenous communities that maintain strong connections to traditional astronomical knowledge also show elevated rates of genetic activation. Groups that have preserved oral traditions about visitors from the stars, ancient technologies, and prophecies about humanity's cosmic destiny are experiencing genetic changes at rates that rival space industry populations. This suggests that the cosmic biological network recognizes not just technological readiness, but also cultural and spiritual preparation for the transition to galactic citizenship. The genetic inheritance includes not just scientific knowledge and physical capabilities, but also the wisdom traditions needed to maintain social cohesion and ethical behavior across the vast scales of space and time that characterize interstellar civilization. Dr. Maria Santos, an anthropologist studying these patterns in South American indigenous communities, has documented remarkable correlations between traditional astronomical calendars and the timing of genetic activation events. Ancient Mayan and Incan calendars that supposedly predicted the return of the star ancestors aligned precisely with the acceleration of cosmic biological activity and genetic changes in local populations. These calendars weren't just tracking celestial movements, they were predicting the activation schedule for the cosmic biological network. Indigenous astronomers somehow knew thousands of years ago when the genetic inheritance would become available and prepared their communities to recognize and embrace the transformation when it arrived. The preservation of this knowledge through oral traditions spanning centuries suggests that previous activation cycles occurred in human history, but at smaller scales and with less dramatic effects. Each cycle prepared humanity for the next stage of development, gradually building toward the current moment when species-wide transformation becomes possible. But the indigenous prophecies also contain warnings about the dangers of the transition period. Stories about civilizations that gained cosmic knowledge but used it destructively, leading to their own extinction and the sterilization of their worlds. These cautionary tales suggest that the cosmic biological network has witnessed many species fail the final test of conscious evolution. The prophecies describe signs that indicate whether a species is approaching successful graduation or catastrophic failure. Environmental destruction, social fragmentation, and the development of weapons capable of planetary sterilization are all markers of civilizations that are failing to demonstrate the wisdom needed for cosmic citizenship. By these criteria, humanity's current trajectory is deeply concerning. Climate change, political polarization, nuclear weapons proliferation, and the development of artificial intelligence without adequate safeguards all suggest that we might be following the same path that led to extinction for countless previous civilizations. But the prophecies also describe a narrow window of opportunity when conscious choice can alter the trajectory. A brief period when individuals who have accessed the cosmic genetic inheritance can influence the direction of their entire species. The children displaying cosmic memory syndrome, the astronauts with activated genetic modifications, the populations experiencing accelerated evolution in response to cosmic influences. These individuals aren't just receiving personal upgrades, they're becoming the seed population for a new phase of human development. If they can successfully integrate their enhanced capabilities with wisdom and ethical behavior, they could guide the rest of humanity through the transition to galactic citizenship. If they fail, if they use their abilities selfishly or destructively, they could trigger the same cascade of self-destruction that eliminated their cosmic predecessors. The choice isn't being made in government buildings or corporate boardrooms. It's being made in the minds of children who dream of other worlds, in the enhanced consciousness of astronauts returning from space, and in the genetic awakening happening right now in populations around the globe. We are living through the most critical decision point in human history. A moment when the cosmic biological experiment that has been running for billions of years reaches its culmination, and conscious beings must choose whether to embrace their galactic inheritance or repeat the failures of the past. The acceleration of panspermia activity isn't slowing down. The genetic modifications aren't stopping. The cosmic countdown continues regardless of whether we recognize what's happening or prepare for what's coming. In less than 6 years, according to Dr. Chen's mathematical models, the current cycle will reach its peak intensity. At that point, the choice will be made for us by the cumulative effects of millions of individual decisions happening right now. The cosmic biological network will evaluate whether humanity has demonstrated the wisdom and capability to become the next generation of galactic life-seeders, or whether we'll join the dark regions on the star charts as another failed experiment in conscious evolution. But there's one more piece of evidence that changes everything about how we interpret this cosmic test. Evidence that suggests the outcome isn't predetermined, that success is possible, and that we might already be closer to graduation than anyone realizes. Evidence hidden in the most recent atmospheric anomalies that shows the cosmic biological network isn't just evaluating us, it's actively helping us succeed. The rain falling on your roof tonight might carry passengers that have traveled for millions of years to reach this moment. The genetic code flowing through your veins right now might contain star maps drawn by civilizations that existed before our sun was born. The dreams your children have about impossible worlds might be memories from cosmic ancestors whose greatest hope was that someday, someone like you would understand their message. We stand at the crossroads between two universes of possibility. In one, we remain forever earthbound, fighting over the scraps of a dying planet while our cosmic inheritance remains locked away in dormant genetic sequences. In the other, we embrace what we've always been, not natives of this world, but children of the galaxy itself, carrying within our cells the accumulated wisdom of countless civilizations that faced this same choice across billions of years. The evidence surrounds us like cosmic breadcrumbs leading toward an inevitable conclusion. We are not alone. We never were. We are the latest chapter in a story that began in the depths of space and will end among the stars. The question isn't whether life came from space. The question is whether we'll have the courage to return home. The countdown continues. The genetic switches are activating. The cosmic biological network is watching and waiting for our answer. In the dreams of enhanced children and the transformed DNA of returning astronauts, in the mysterious objects passing through our solar system and the accelerating reign of biological anomalies, the universe is asking us a simple question. Are you ready to remember who you really are? The answer will determine not just our survival, but whether consciousness itself has a future in a cosmos that seems determined to eliminate it. We are the universe's greatest experiment in self-awareness, and the final exam has already begun. Choose wisely. The stars are waiting.